It's 9 p.m. It's Friday night. What the hell am I doing streaming coding? And in the latest in the news, actually I have no idea what's going on at all. I think our economy is getting some extra injection, and maybe that's just America. Boris Johnson is in a bit of trouble. Everyone's arguing. London are, I think, out of the lockdown, but here in Scotland, far too sensible for that right now. And it looks like the old COVID-19's on the increase again. Just a little bit, just a little bit. Howdy! Oh my goodness, what happened? Oh jeez. Oh, there we go. It's a little bit better. Man, I am not ready. I didn't do any sort of prep today, as you can see. I'm totally out of focus. And I'm wearing a really weird skin-colored t-shirt. I didn't prep at all. Oh my god, I've not even got my hat on. I've got my big, yep. As you can see, losing all my hair. Anyway, on with the show. What we're looking at today, we're going to complete Dijkstra's pathfinding. Big shout out to 1Bit. Awesome show. I learned so much actually in the last one. I missed a big chunk of it, so I need to go back and watch it again. But if you haven't tuned in and you want to learn a lot about Godot, if you actually want to learn something about Godot, my god, check out 1Bit. It's really good. I actually want to just rewrite everything now, especially having just watched that last episode. So, better turn on my old Chatteruno. This is the thing about Restream, is that I'm not really in YouTube or in Twitch. I'm just somewhere in the middle. So, I've got a protest video. Look at that. A slow motion protest video I used today in a meeting. It's useful. And Godot. Jolly good. Let's fire it up. Have a look where we are. So, turn down the audio. We'll switch to some atmospherics, shall we? There we go. And let's have a little look. So I was so excited yesterday to have this working. Our character now, one of our characters now, moves around. We could add more. I'm pretty sure, pretty safe bet that our characters are moving around. Here's our AI.
Hi.
Hey, 1Bit. Great show, man. Fantastic. Really good. I've learned quite a lot. I was just saying I want to rewrite everything now. Just start again with your engine and add the audio stuff on top. Oop, trash in the place. There goes my tablet. Oh, jeez. And my coffee cup. Oh, there's the AI coming out of the lift. Although I don't know if that audio is right. I'm going to have to work on those transitions. She'll come out the lift, the door's shut, and then she walks off. But really, we should hear the lift coming down. Or, if she's in the lift with us, I mean, she should be only allowed to come into the lift at this point from this floor. So we should hear the doors open and her come in. But she shouldn't be allowed to traverse up to the second floor unless we go up with her. Unless we let her press the button. But I don't think we should. I think we should just have her saying, floor 2, please, or something like that. Far too much detail at this stage, but there you go. That's what happens when you integrate lifts into the equation. Tricky things. So, yeah, so our AI is moving around, which is happy. And we were just coming to that crunch point yesterday. We're trying to get actual pathfinding working. Is our AI in the balcony? Yes, they are. Is our cutscene still working? Yes, it is. Hold on. To remind myself how cringy my voice is. Actually, no, I can't bear it. Right, so let's have a look and see where we are. So we can see all this output getting spat out here at the bottom. Oh my god, the fuzz. The fuzz. I'm going to have to check my filters and just tweak my green screen settings here. Hold on 2 seconds. So my head will disappear. Where is it? It's this one here, isn't it? And I'm gone. And bring me back. Tron style. we go. That's better. We're going to turn at a weird angle and my head will disappear again. Right. So I am really far over this side, aren't I? I'm just going to move myself over here.
The string is gone.
The string? Oh. Yep, I've hidden the string. I'm going to order myself a green shoelace as well, just in case. It'll make things easier. It really is just a shoelace up there. That's holding. I roll up my green screen. And would you like an office tour? Let me give you an office tour. Hold on. This is my studio. Where are we now? Turn the filter off. How do we turn off the filter? Can we just disable it? There we go. There's my green screen. And so I just roll this baby up, right? Up to the ceiling. And you can see the squalor I'm living in. This is my room. I spent my entire life in this one room. I've got VR on the ceiling. You can see that up there. Oh, and my bed on the floor. So I work here, sleep here. Everything is done from this tiny little room. Does me well though. So let's have a look here. Oh my God, I forgot how excited I was at getting to this point yesterday. I really was. So one bit, with the help of one bit.
Sounds cozy.
It really is. Yeah, very cozy. It won't be. I'll be less cozy after the lockdown when I can go back to my house. But at the moment, I am. It's one bedroom. That's for me. So at the moment, I've got locations getting spat out here, and we can go into what script was it? It wasn't event controllers, but we can see here we're stepping through our character. We're checking the schedule to see if it needs updating. Then we're checking the behavior to see if the character needs to do anything. And we can delete all that. Yay. I think it's the character script. Yep. So here we go. So we can see I was doing some testing here of objects. So with a bit of help from one bit and a mysterious visitor yesterday, I finally got objects. Really actually got my head around just scripting objects as opposed to using them in the scene here. And it's pretty handy. So I've got I've got all my locations in an array. I'm storing the distance between. I don't even know if I need to do that. Oh no, I do need to do that. I need to store a distance value on each location. And I need to store, what else do I need to store? Let's have a look at our location object. Oh, it's not a location object. In fact, you know what I'm going to do? I'm just going to always do this. Close all the blooming tabs. Nope, don't want location. I want root node. So there we go. So we've got a location name, a distance, and whether we've visited it yet or not. And if you're not sure what that's all about, have a look at the last video or go look up Dijkstra's algorithm and see why we need this on a per node basis. And character. Scroll down to my path algorithm, pathfind. So we want this algorithm to return an array, which is the path from one end to the next. So we can set our character just moving along that line at whatever speed they're defined to move at. So this was just a little test to see if how to use an object. So one thing I realized here was that when you create an array, if you define an object and then set some variables in it and add it to the array, and do that again and again and again, you're just adding the same object regardless of whether you change these variables or not. So if we added 10, if we did this 10 times, oops, well, that's not how you do the control D, is it? There we go. If we did that, all we're going to do is end up with the same object in the array 5 times. So if I changed object to 15 here, and 25 there. All I'd end up with is all of them saying 25. It's the same object. It's a pointer. So we have to actually create the object, set the values, add it, and then create a new object, set the values, add them, and so on. So one bit yesterday gave us the secret to stepping through our groups. That was blooming amazing. So on my list of to do now is to actually update my other nodes. I'm really going to do that just really quick because it's just so important. So I'm just going to add to object. This is it's now going to be called items. I'm going to be changing the word object everywhere. That was a really bad idea. Or tokens. I'm not going to go the same route you've gone one bit. I'm going to try. I think you've just come to the realization that I already had, in that my characters won't live in my scene tree within a location. They just have a location definition. Although I've got a node path. Just honestly, the node path stuff is just an absolute nightmare. And having seen you just quickly solving that problem, I spent, I think, at least 2 episodes talking about and then I ended up creating these global scripts, which I think, no, I don't create the global. I create them in character. No, location. Nope. My God, where did I create them? Yeah, I create them in character, which take the node path and they get me, because currently the node paths they're relative, right? So they break. So what I did is I extract the final target location. So what's the node called? Not where it is. And then I find the node wherever it is. And so I'm actually just I'm just getting I'm actually just getting the current location here.
Are relative to the node that are assigned to.
Yeah, so if you use extract node, which is my global function here, which all it does is return node path, get name, node path dot get name count -1. That'll give you the actual node within the node path. So it just gets you the name of the node, and then you can just search for that node. It's a really crap way of doing it, but it worked. So now I can just find a node just by basically getting it in my own way. Of course, what that means is that if I have a duplicate node name, I'm screwed. It's just going to get me the first one. So yeah, it's not ideal. But as I said, my philosophy is to complete this prototype as quickly as possible. So let's get on with it. Back to our right. So we've added this to object node. I'm going to rename.
It's easy if we write code to get the node path at runtime. Just call get_path on the node.
All right. Isn't the problem though that if you move the node, then now you don't know where it is? What else have I got? I've got object location, exits. And I really liked your functions for getting locations, get all of them. Give me them all. That's a great idea. I might do that and stick it in global. It just becomes easy just to utilize it wherever. So I might just do that here, because I'm going to use it anyway.
You get the absolute path, but if it moves, it breaks. That's why I decided that my nodes will never move. But I won't be using node paths, so it won't matter anyway.
Yeah. Yeah, I don't suppose I really need to move my nodes at all. Well, apart from my objects, right? I wanted my objects to have a, first of all, whether they can be taken or not. So I've got item on off. which is going to, obviously, now I'm going to rename this to item anyway, so... But I wanted to say, yes, they could be taken, and then whether or not, essentially, they were in the inventory or within a given location. But, yeah, I've messed that up. I'll come back to that. I think I'm going to have to go down a similar sort of road.
That's why I separate fixtures from tokens.
Yep. And you know what? I'm going to come back to this later and go, ooh, how do we do again? What do we do? And I'll probably get it wrong. But, yeah, no, that makes total sense. Funny, I just realized it now looking at my code. Okay, perfect. Right, so I want just a couple of functions here. Get locations. I've got to start doing this, right? Oh no, it's going to return an array. Is that right? Yep. And we want 4. Get locations. Characters. I should have just done 1 first and duplicated it. Get items. They're not going to be objects anymore. And get exits. And eventually get tokens. I don't know about the word token. I always think of security when I think tokens. But yeah, defining a fixture makes sense. You just have fixtures and items. Pickables, collectibles. Right, okay, so I've got a partial script here already. Just up here, there we go. And back to global. So we're going to have a location list.
I use dictionary so I can locate an object by name instead of node path, but if you just want a list, you can just return as an array.
Yeah, I think that's what I'm going to do. I think I don't need a... Wait. Oh, I see. Yeah, I don't know if I'll need it. Yeah, I can always tweak it if I do. I mean, I can locate an object by name within the array. In exactly the same way, right? You're not... No, I'm just returning a list of strings, right? So... I suppose because of the way I'm referencing things, I'm grabbing a node. So I identify nodes by string. So I do want an array of strings. And then it's location underscore list dot append. Is that right? Is it append? Location.
Dictionary is just faster. You can change it later if you need to, so stick with array first.
Okay. There's certainly no need for speed. I'm really, I was thinking about the visuals the other day, and I really would like to go for. You were giving me some inspiration there, and what I really don't want to do. I don't want to. Shut up, Google. Why is Google coming up? Let me turn Google off. He's talking to me. Yeah, so you gave me some inspiration showing the different adventure programs of old. And honestly, a lot of that stuff's taking me back. I used to love adventure games when I was younger. I was like Zork and some crazy explicit text adventure games back in the day. But yeah, I was just thinking, I really don't want visuals. I really want to stay away from it. I'm trying to give this a feel. I really like those the books, the adventure books, but I think that they're really limited, and especially I really have a dislike of audio books that just like take you from one step to the next. Just think like you could have so much more depth. So what I'm thinking is that let's see if there's any sort of games, audio. I don't know if there's going to be anything like that, to be honest, but I'm thinking like a game that uses a book as its premise. So I'm thinking maybe the pages open up and the options are like kind of written, and when you take an option, it's like the story's being written for you. Maybe a technical version of that. Maybe it's like a terminal, and you're writing the book as it happens. But it doesn't need to. I think the GUI guys really wanted to make whatever this interface looks
Sounds like Inkle.
Maybe, yeah, not really. I'm not envisaging that. I'm thinking more along the lines of, because it's got to be more interactive, right? It's got to show characters. It's got to show the locations. It's got to show objects. You've got to be able to use the verbs and click on things and do more. So it's, I still think there's kind of like a technology based book. Maybe I should just have an iPad there and people just clicking it, and that's just bizarre. A game of someone pressing on an iPad to play a game. Perfect. Forget that anyway. I'll get back to this. That's just like the worst idea ever. It's certainly the worst description. So, indented block expected. Where's that? Is that further down? Yeah, it is. So we want to return location list, and that should be it, right? Okay, we do that with characters. Oops. And I'm just going to do a blimey. Oh, insert. Let's take that. Oops. Oh man, can't type today. Okay, for character. List of characters. Okay. And items and exits. And so that's going to be items list. Item. Items. Item. And items. Items. This is the most boring bit of the stream. I need to tell you a story, an exciting story, whilst I write this stuff in. I can't think of one while I'm working. Exits list, exits list, exits list, exit. All right, are we good? Character isn't declared. No. Oh, exit. Super duper. And actually, that's a point. I don't think I've set this in character yet. Nope. Pretty sure I haven't. I'm just going to, yeah, grab that, add that to our character class. Ditch process. Characters. Characters. Yay. Great. Nice. New globals to play with. Happy days. I just have to put in my notes, even though it's absolutely obvious. I just want to keep it explicit. Exits. Okay, so close that. And close that. We'll come back and rename that later. I'll just test it, make sure it's still running. Ooh. What? Attempt to check schedule in base previously freed instance on null instance. Somehow I've managed to, my character has freed up himself when he, why did he even exit the tree? Ah, right. Oh no. One bit. We have an issue. Because when I exit the tree and I move my character around, because my character is, no, my character isn't moving around. It's just updating his location. Have I missed one somewhere? Exits, locations, objects. Yeah, it's all Good. Wow, I have no idea what's causing that. Check schedule in base previously freed instance. So basically it's saying that my character no longer exists. I seem to have got rid of him. So I've done something. I'm pretty sure it's something to do with exit tree. If I just comment these out. Play it again. Yeah. It's weird. Just going to check my remote and just see how everything looks at the moment with this kicked in. So we can see locations. We can see our objects inside our locations. Ooh! The exits have gone. So it looks like I can't go anywhere at the moment. Yep. Crash. Oh! I think I'm using the exit scripts for my buttons. In fact, I'm using a lot of this stuff as part of my... Okay, so I need to update the game script. So my buttons are being added to a group called exit. It should be exit buttons. Right, and then what are we ditching later on? Our exit buttons group. I need to update this stuff as well. There's so much fixing to do, but I'm going to have a day of code optimization. There is a good hold on, what's it called now? Godot project. I actually asked this guy to create a video on it, and he did. Here we go. John Watson, 6 months ago. Highly recommend it. He basically talks about exactly how
isn't actually in the game itself.
How he sets up his projects, and it's a really good way. In fact, it's a brilliant way. And the main thing is that he organizes.
If you use Q_free, make sure those objects are removed from the group as well.
Oh, okay. So yeah, so that's what I'm doing, right? So make sure that those objects are removed from the group as well. Oh, right. So but they'll. Oh, I see. Right. You mean with the exit? So this. Do I do that before I? Really? Is that not automatically just like ditch them? Right. So. Stick it in. Right, so look, here we go. Characters. So this needs to be character buttons. So that was the problem. So this is character.
Are buttons in the locations groups?
Yeah, they were. 100%. That was definitely a problem. Here we go. Let's just up a bit. Objects. I'll come back to that later. And where's locations? Did I do locations already? Exit buttons. Oh no, it's just exits. So locations are fine. It's just exits. We should be good to go. Happy days. Buttons. Press. Nothing happened. We're already on this floor. Button 2. Happy days. See the way it doesn't update the GUI when you're in the lift, because you've not really moved location. And then that for me is a page turn. You change location, you turn the page. but you're staying in the location. And then I could have on the left side, like the characters that are on. So this is just me going back to the book idea. So you've got your pages on the left side. You've got here's in the character. You could have all the characters sort of stacked up next to each other that are in the location. And when someone exits, they just sort of fade out from the group. And then you've got some kind of like, I don't know, book description on the right. And then if you hit options, it'll like switch to the index, and then you scroll through you've got the index of contents as your settings, so everything's within a book. I thought that might be cool, because then you've got
I get your idea.
Thanks. So when you've got a new book, a new game is a new book, and they open it up. Anyway, it's just me not wanting to develop any assets whatsoever apart from audio. Character buttons. Okay, so that's cool. So we're done there. Close game. And take a note to check rendering resolution for Twitch. I didn't look up that problem. But I did reduce time delay. How is that? Does it seem very responsive right now? 1-bit Godot? Doesn't sound like it. So, okay.
Yes.
Yeah, all right, cool. I wonder what the delay is. If I go, I am typing this message now. Looks like I get maybe a second delay.
It's faster.
Definitely cool. You know, are you using OBS Streamlabs or OBS? Because that setting is in Twitch on the settings page, and it's low.
No, I'm using Twitch Studio.
All right, it's a setting on Twitch, in the Twitch settings. It just says low latency. You've got the option for low latency or normal. So you turn it to low latency, and voila. I think, when we're coding, we have such little requirements, so we can really optimize our stream much more than those people that are blasting out 60 frames per second 4K video. I just ordered a new graphics card as well. I'm going to get myself one of these ray tracing things. Not that I need it. Like, ray trace this book, the text that's written on it. But I just realized, I was chatting to someone yesterday, I just realized my PC is 6 years old. So it's time, I think. I'd start replacing some of the bits. Where are we? Character. So I can now use.
I switched down to 30 FPS, so the stream was okay for you.
Oh, it was perfect today. Yeah, absolutely spot on. It definitely made a difference. It's that will have halved the bandwidth you need, presumably, if you're streaming at the same bitrate. So I'm guessing. I'm not entirely sure. But yeah, it was perfect today. That said, it is a new internet, mate. So all locations equals g dot get locations. Oh my god, it's so nice. So easy. Right, now I can step through all my locations. In fact, actually, can I just for locations in g.getLocations, can I do that one bit? Is that allowed? That would be pretty slick. In fact, I'll just test it. I should still get a big list of locations at the bottom here. Yay, it works. Okay, now, here's the juice. So this is where we've got to do our Dijkstra stuff. This is where my head is going to melt. Right. Create a list of all locations starting with your current location. So that's something I haven't done. I haven't identified the current location. Can I reorder the... I'd like to make these... no, because we need to work through all locations and tick them off as we go. And for each location, we need to go and check the exit and see what's connected to it. And once that's done, we move on to the next one, and we only check the ones that we haven't checked yet. So we wouldn't check if it was connected to that one. We'd only check. So we'd only check stuff that's all not been visited. It's just the order of which we go through the locations. Apparently, you're supposed to start with your current location. Does it matter? I suppose it does. Okay. What's our current location? It's our start location. So, of course, this is where the dictionary might be useful, because now I've got to search for this string inside the array. Let me just look up the old Dijkstra. Oh, I can't print. I can't even type it. There it is. Dijkstra's algorithm. We're not supposed to go through the locations in a particular way, are we? We're supposed to go through the locations in a way that we're checking nodes that are connected to one another, right? But then if I checked A and then I check E next, yeah, I'm checking I'm creating a list of nodes that are connected to the current node, and I'm stepping through those nodes and creating a new node network. I just do not get how I'm supposed to step through it. I'm sure it's a lot easier than I'm thinking it is. In Java, let's have a look. So these all have order to them. Okay, so we have a set of nodes. That's exactly what we've got so far. Here is a node. It has a shortest path. Oh, shortest path. I'm not storing that yet, are we?
How does the exit connect to another location? Are you using node path?
Yes, I am. So I will step through exits for my given node. So I'll get the node that is in my list, and I'll get all the exits for it. I've got a script for that already. And then I'll check out from there. I don't need something as complex as Dijkstra, but I'm really keen to sort of work my way through how it would work. I'm actually thinking I might add distances between the nodes, just because why would someone take this massive route through a long corridor?
Then there is no need to get all the locations. Just go through each exit to retrieve the next location.
See, that's what I thought, but look at this. So if I go, if I start here, right? Okay, so I start at A. It gives me two locations, so I check these. That's done, right? How do I decide where I'm going to go next? Well, let's say I'm going here to B next. So B is connected to D, and I haven't got F. I haven't got E. So let's do it like that, okay? So I go to B next. Right, that's done. Okay, yeah. I mean, it's just going to keep going round, right? So I'm getting the current node, and I'm creating. What do? Am I creating a list of objects I want to do next? How do I decide which way I'm going to go? I'm creating a distance here. So let's say I go this way. Let's say there's no connection there. Yeah, so I go A, B, and now I'm over here, which is great, but I never check here because I've just stepped through my locations, my exits. How do I decide that I actually need to go here first, check this one before I go over here and make this the next current node? So in this case, you can see the red dot. That's the current point. So then we decide to move to the next one. We now need to pick a new current node. That node must be the unvisited node with the smallest minimum distance. Oh, because it doesn't matter what the other nodes are. That also doesn't make sense, right? Because if we do decide to use a minimum distance, and this one's 10, and this one's 2, then I pick the smallest minimum distance. I go down this road, and now I'm done, because I'm at a dead end. I never actually reached my destination, which was maybe F. So what they're doing here, calculate shortest path from source. Am I thinking about this right? One bit. I know this is not my forte. I was wondering if maybe, because so that's the very reason why I thought we'd need to have all the locations, because I want to make sure every single location.
You have to use a recursive function.
Right. But doesn't that then mean that I have to check all nodes? That I mean, I have to have all locations. Recursion isn't one of my strong points, to be fair. I don't really use it much. I can apply it to really simple stuff, but I'm trying to imagine how. Let's just look at this code here. So this is JavaScript. Calculate shortest path from source. Calculate shortest path from source to what? If graph is the actual set, the node set, and source is the node that we want to calculate the distance from, then where are we going to? Or from? From source. Yeah, you're going from there to where? Right, okay. So it's going, okay, right. So we don't have a target node. It's working out the distance for all the nodes back to the source. So source would be our current location. So we set the distance to 0. Then so we're setting new hash sets for settled and unsettled. So we're just initializing. I haven't done Java in about 25 years. So now we're adding our source to the unsettled nodes. So this is our first node. So we're actually creating this list as we go. Okay, all right, I'm just going to try and emulate this code because it's kind of making sense. So let's have a go. So We've got all locations at the moment, which is a graph set. And we're going to create... I don't know what's happening with my insert key. I must be tapping it by accident. We're going to have settled nodes and unsettled nodes. Oops. And these will be arrays. Okay. I think working my way through like this will help me understand it. So we're setting the distance of our first. So in this case, then we don't have an end location. I do want to have an end location, but I don't need it at this point. I'm just creating this graph first, right? So what this is suggesting is we have. Can we do that? Can I say that that's a? I don't really need to do that, right? This is just. I mean, okay. This just doesn't have any application right now, right? Source.set distance 0. I need to. Oh man, head scratching night. Can't believe it's 1:45 already, and I'm only here. Right. See, this is why I thought we'd need this big list of locations, because actually I want to go and find my start location in my list of locations, create an object for it, and then set my distance to 0. So it would be like this, right? Source equals this. My distance is 0. My
Difficult
name...
to explain in chat, but I'll do a sample and you can check it out later if you still have problems.
Okay, thanks, one bit. I think, yeah, it is difficult, you're right. Location name. I'm going to try this. I'm sure I have a way of stumbling through things like this. Unknown character. Ooh, where? Wow, do you see it? Still got it. Okay. I've had a weird character there for some reason. Right, okay, so source node is a new root node, its distance is 0, and its name is the same as whatever the start location is, right? Way. So I've now defined my starting node point. Is it visited? No. Visited will be false. Super duper. I'm now going to add that node to unsettled, right? So unsettled nodes append source. So we're creating our graph. And we've got our starting point. And I think you're right, one bit. I don't think we need to have all locations, but we'll see what happens. So let's put passive there. Get rid of this arrow. Okay. So we declare our starting point. Put 0 distance. Initialize containers for tracking our what's the word? Tracking our work, I suppose. Process. Okay, right. So next. So step through. Well, okay. Well, here's the recurrence. So it's going to continue to add adjacent nodes to unsettled nodes. So it's so as long as there's still unsettled nodes to work on, Yeah, that makes sense. God, I would never figure that out. I really wouldn't. Maybe I would, but it's nice to see it there. Okay, so that makes sense. Okay, so one step at a time. So, zoom in a bit here. Switch to coding. Ooh. Don't know what it is about my screen, just randomly adjusting its resolution sometimes. There we go. So, okay. I don't know if we can use a while loop, can we? Unknown character again. Jeez. Don't know where that's coming from. You get unknown
Yes.
characters. Yes. Sweet. Excellent. Probably those spaces, I think. Yep. Okay. Right. So, is it dot size? Yes, it is. Yay. Okay. So while unsettled node size is not equal to 0, so at the moment our unsettled node size is 1 because we currently have our starting node. So we're going to process all the exits from this source node. We're going to add any target locations we find from those exits into the unsettled node, and then we're going to keep stepping through, and that's our recursion loop through every single node in the graph. Hopefully. I'm sure it'll work, but I'd love to see it visually when it's done. Anyway, I'd like to create a big complex graph. I love this stuff. It's so cool. I feel like I've been missing out on so much fun just working on websites every day. Okay, so I kind of want to work this out for myself now, but this is nice and clean. Let's just see if it looks. So we're picking the next node we're going to look at based on this lowest distance. So what we do is we pass in all the unsettled nodes and we get the lowest distance node. I don't know how that function works. Oh, here it is, because obviously that won't always be the case, right? It might be infinite at the moment, or 99999. Oh, look, he's using null. Look at that one bit. What can I say? That guy had a major issue about null, which I still don't have the answers to. I want to know what the big issue is. Node. All right, okay, so they're just basically giving an example here, building it up.
Like I said, null is still necessary in a lot of cases.
Okay. So get lowest distance passes in a list of unsettled nodes. It then sets lowest distance node to null. Initialize lowest distance integer value to max value, which is an enum of unknown quantity. I suppose that could be our 999. It's some sort of infinity value, presumably. Then steps through all the unsettled nodes. Runs another function that we don't have, which is node get distance. Oh, it's probably just getting the distance from itself. That's something we set within the node itself, right? Distance. Then, where is it? Then it checks to see if that's the shortest, essentially. Is it the lowest? And it keeps working through until it comes out with whichever node has the lowest distance, and then returns that node. Okay. we can rewrite something like that. Let's just pop that in then. So it seems a bit weird sticking all this stuff in character right now, but I suppose it's the only things that we'll need to use it. So, okay, so function, get lowest node distance. Yeah. And then we're going to pass it in, unsettled nodes, which is, hey, I remembered how to do it, an array. But it's an array of our objects. Hopefully that will work okay. So the lowest distance node is a new one of these. So how do I do this? Like this. So because we're going to be setting this to a, is that right? I think it is. So we're declaring a, because it is a pointer to one of the elements in the array. Or no, maybe it should just be, because it's an array pointer at the end of the day, right? So just var lowest distance node equals null for now, not 0 basically. Oops, let's get rid of this stuff. And so it's going to return a integer. I think. Do we want it just the index? Get lowest node distance. I'll come back to that. I'm not sure actually. What we're returning, we're actually returning a node reference here, so I think that's right. Indented block expected. Spaces. Okay, and then we're setting an integer. So var lowest distance equals, and for now we'll just set it to 99999. It's got this max value in here. What are we setting a root node? That. Okay. We're never going to have anything that long. Oh, we've got an unknown character in there again. Fantastic. I think it's just that. Oh, could be. Oh, yeah, I think that's it. Right, okay. So now we're stepping through our unsettled nodes. For node in unsettled nodes. Okay. Right. So now we can just do node.distance. And I have to declare this first, right? Node distance equals node.distance. Okay. So then if our node distance for our current node that we're looking at in unsettled nodes is less than the lowest distance, which is 99999 in our first instance, then our new lowest distance equals whatever that node distance is. Great. Okay, I've got a semicolon in there. Expected, yeah, okay. Oh, crap, yeah. And then we're updating the pointer. We're saying our new lowest distance node is this node here. And then we're passing it back. So we're not actually passing back an integer. We're passing back a root node, which is down here. So that. Is that going to work? Cool. All right. So we've got lowest. So this gets the lowest distance node in unsettled nodes. Essentially, returns. So let's look back at how that's utilized then. So we are stepping through our unsettled nodes. Let's hark back to an example here. I haven't calculated a minimum distance yet. I'll have to do that in a sec. So now we can set the current node. Set the current node to get less distance, and then we're removing. Why are we doing that so early? We're removing the current node from unsettled nodes. Oh, because we're about to process it. That makes sense. Just, I suppose I'd have probably done that later and then realized that I needed to do it sooner. So, current node. We're going to need to declare here. Well, that just works, doesn't it? We've written that. So we're getting the current node that we want to process here, and then we're getting rid of. Let's just change this, change that, and this is also a. Do we have to do it like this? I think we might. Let's put it in the statement. Oops. Okay. Identify unsettled nodes. Oh yeah. Right. Okay. As long as my object declarations are working here, what's going to happen the next time it loops? Yeah, that should always work because we've defined this. Hope so, at least. Wow. This is connecting the synapses. So, all right. Wow, what's going on here? Jeez. Okay. So this is the crux of the algorithm, essentially. Let's have a look. So for what?
I have to go. Bye.
See you one bit. Take care, mate. Have a good night. Catch you tomorrow. You're going to be streaming tomorrow? Oh, I just drank yesterday's coffee. I need to clean up. Oh my god. Ugh. I have to wash my mouth out a bit. All right, I have no idea what's going on here. One bit picked the best time to go, just to get stumped by a bit of Java. So it's saying, I think, that entry is a node type. Adjacency pair is an integer. I have no idea how that works in a for loop. Oh, it's because it's broken into 2 lines. Jesus. Right. Okay. So it's a condition. Oh, man. Yeah. This is already a little bit too much for me. So we're basically setting node here, entry. So it's saying we're going in at this point here, and we're setting something called adjacency pair. So we're setting the node that we're next to be the current node dot get adjacent nodes dot entry set. Blimey. Okay. Then it gets a key value for our adjacent pair. It gets the edge weight, so that'd be like the distance, right? And if our settled nodes doesn't contain this existing node, this adjacent node, then we're going to add it. We're going to calculate the distance and add it to our unsettled nodes. Because we're going to want to do that later on. Oh my god. Right. I'm going to keep this in there, but I'm just going to rewrite this based on what my understanding is. Okay. Loop through each exit. Loop through exits to other locations. Only increment distance. So we need a function for getting all the exits for a location. Have we got that already? No. We get to get that. We've got a function in game. In which we get the items, so display exits. Gets the current location. And it then gets all the exits for that location. We could actually extend our global function here. We could do something cool, I think. Yeah. So a bit like this. But I don't think we need to. Might be overkill. I'm going to have fun referencing these objects later on. My goodness. I think I'm going to have to sit down. My brain is using too much energy right now. All right. Oh, going down. Oh, yeah. Here we go. My table on legs. Trying to crush anything under it. All right. Oh, yeah. Okay. Let's get comfy for this. So, okay, that's handy. I don't think visibility matters. What's this? Okay, so we're going to check all exits for our current node. And we've set current node here. And that's a root node at the moment, right? So we've got to find the location. We've got to set a target location node, which we do in. So I'm just gonna jump the tunes a bit. Okay. We've got to get the location. So we're kind of doing that here, but that's not the way we want to do it. Yeah, we need to be able to look up our current node based on its name, and we wrote some functions for that. Find node. No. What did we call it? I thought we had. I'm pretty sure I had. Where's global? Okay. Maybe not. It converts relative node to single node string, turns current node to a player location. Converts relative node to single node string, turns previous node. So I never did write an actual find function. Okay. Okay, so we want to get node by name. I don't know what the hell it's returning, but it's returning a node. It's one way or another. I just need to block this stuff off because it's not going to work at the moment. Block that off because that's not going to do anything as well. Indented block expected. Where's that? Oh, here. And oh, yeah, I can put that back in. I think right now. Work now because we've changed that earlier to buttons. Super. Right. Getting a node by name from the tree. So how the heck do we do this? We could just loop through the tree and just check every single object and get the first one we find. Seems to be the easiest way, but I'm pretty sure there is a function for this, right? I remember looking at this. It's array functions. Find array. Find node by name. Right. So apparently it's just that. Won't work with instance scenes. Yeah, this is what I was thinking of doing. Cool. So that's all we need, apparently. So I'm going to return all nodes. All right, let's try it out. The identifier obj isn't declared. Right, you are. We're not doing that anymore. So get lowest distance isn't declared. Let's get lowest distance. Okay, so let's try this out. So it's gonna be fun trying to debug this. So I want to get the current node by name, which is location name. And at that point, I'm going to pause it and see what I get. So we'll set this to var test equals, and then we'll just print. Done. All right, let's see if we get there first. We made it there. And we hit an error. Remove in base array. Cannot convert argument 1 from object to int. Ah. So when we remove it, we need to remove an index. So we do need to return an index then. Okay, so with our getLowest function here, a method function, we need to go and we need to actually return the index of the node in unsettled nodes. So I'll just have I'll set up index equals 0, and then idx plus plus here. Oh no, it's plus equals 1, and then actually returning yeah, just returning idx here, the index of the node at that point. So that should return us an integer. And it's no longer going to return us a root node, it's going to return us an int. Let's try that. All right, happy. We hit our breakpoint. We're going to step through. And we've got an error. Can't get index. Oh, of course, because we're no longer passing it through. We now need to pass in the current node's a number. So it's so it's unsettled nodes, right? I'll get us the actual node. Oh, jeez. That's messy. You know what? I'll just do it like this. I'll get node. Oh, man. This is just so... It just feels so wrong. I think because I'm trying to emulate rather than really understand what's going on. I understand what I'm trying to achieve, but I just don't have the bigger picture. It's quite tricky to wrap my head around. So current node index is 0. No. Current node index. We'll declare up here. So current node index is going to be this. And we pass in unsettled nodes. So that'll give us the number. The current node is unsettled nodes current node index. So now when we do our remove, we're removing that from current node, but we've still got a link to the actual node. Let's try that. Okay, step through. Happy days. Let's check our test variable. No, not happy days. So what was our current node dot location name? Current node, there it is. So we just turn on full screen and we can see location name is start location. What? Oh, right, we've overridden it. That's stupid. It should be start underscore location as a variable. Right? I'm not sure what we're passing into Pathfinder at the moment. Is that in above? Yeah. So start location should be living. Let's go for the balcony. And our end location is the. Let's go for the elevator living area. That means they have to make their way from the balcony into the living area and then into the elevator. So that's, we should come back with three steps there. And I'm going to print output from that. Okay. Let's try that again. See if we get an actual node this time. Maybe we should be checking for null. What do you think, guys? Null check there? Where's test? Hey, it worked. So we can see that our get node by name has returned the object that is the balcony, location name balcony. So, and all the goodies that come with that object. Fantastic. Right. Oh my God. This is a lot tougher than I thought. It's all very well just implementing pathfinding, but then implementing it into your solution. Knowing what I know now about how this is done, I think I'd rearrange this better, and I'd probably use a dictionary file like one bit Godot did instead of an array. Easily change later, but yeah, I'll keep going. So, all right, so that I'm getting the node that I want. So I've actually got the node. So, what should I call this? I don't want to set a new var every time. It's really current node, right? But it's like current actual node. Jeez. We'll call it target node. So it's the node, the actual node in our tree. Okay, so now we've got that. Now we can step through all the exits under it by just looking for the children. So for exit in target node, get children. But only if it's not null. I gotta put in this. If target node equals null, then push error pathfinder found an exit. Sorry, a location with pathfinder was given a non-existent location, and then pass in whatever we got, which is going to be whatever this is, right? So it tries to get node by that, so pass that through, and then we'll get a nice fat error if it hits that. Too many arguments. Oh yeah, it's plus. Super. Right. Okay, so now we step through our target node. We get all the children. So we've got all our exits. It's like I've got to add this whole new layer every time I take a step through the algorithm. So I'm not just doing this, I'm having to get all the information that I'm going to use with this. I really like the sort of functional description here, rather than looking at that code. I stay away from that Java. So we've done this. Mark your selected initial node with a distance of 0 and a rest with infinity. We haven't set the rest though. The rest don't exist yet. Set the non-visited node with the smallest current distance as a current node C. So we've done that. And then for each neighbor of your current node, add the current distance of C with the weight of the edge. Doesn't matter what the weight is because we don't have any edges. If it's smaller than the current distance of N, set it as the new current distance, and it's always going to be the same. Mark the current node C as visited. If there are non-visited nodes, get to step 2. All right, so we're getting the exits here. Now we need to get because the exits are nothing, they're just pointers to new locations. So and obviously we only want to get can we check if they belong to a group rather than this instance name stuff? I want to get rid of this. Let's just check that. Godot belongs to group. Hey, check if a node is part of a group. Body is in group. There we go. Nice. Sweet. All right. That would be nicer, right? So if exit is in group exits. Sorry, if exit is not. What? If not exit is in group exits, continue. So only process exits. All right. So at this point, we have got a location. So we can do this again. We'll call it, so let's set up adjacent node. Because that's what we're essentially doing right now, right? Adjacent node. So adjacent node is now set to get node by name. And we're going to look up our node based on our exit. And every exit has a property of target location. Now, I think we need a new little property here. Path target location. It's a node path, right? It's just a bit shit because actually we want a string right now. If this is going to be a recursive function, we just want to be accessing it the same way we access it up here. So, what functions do we write here? Yeah, so it's this extract node. So we just want to get a string. So we're going to extract the node from our exit dot target location, target underscore location. Yeah. So that should get us a string. And if we print that out, oops. We should get, oh, what have I done wrong there? Or is it expecting a comma? What's wrong with that? Oh, close bracket. Okay, so at the moment, we should just get this for one function, right? And it's going to be balcony. It's our first location. So if this works, then if we look at the balcony object, it's only on one exit, so it should just give us this exit here, living area. But it shouldn't give us exit living area. It should actually take us to this node, living area. That's what we expect to see in the printout. What do we get? Ah, we actually get the node. Oh, of course, because we're using get node by name. So we are actually getting the node 1490. And if we go into remote here, we find the living area node and we check it. We can see the ID here, 1490. Yay, we got the right node. What's this though? We've got another node that doesn't exist. Why? Wow, look at that. You can breakpoint it live. That's so awesome. So, so if I step through this one, and we look at the adjacent node, 1490, happy days. Have we gone to the print somewhere? I think so. Okay, we step. We step, and we should see, I'm going to clear this out. Step. Node. Okay, fantastic. I'm going to continue. Pauses again, check the output. Ah, we have got a print somewhere. We've got another print somewhere that's printing out a it's printing out an empty array. I wonder where that is. Let's just test that hypothesis real quick. If I comment that out, we should just get empty arrays getting printed, right? So, clear. Continue, continue, continue. What? 6 less than 4. No, it isn't. I have to get rid of that. A massive debug where I was like thinking my if statement was inverted. Okay. Oh, here it is. Of course. Right, you know what? I'm going to just print path find returned. Right, that's what, I mean, that ultimately that's what we want to see. We want to see a full path come back here. The actual path our NPC is going to take through our map. All right, okay, should be good to go. Shouldn't be any more crap in our debugger. Should be just run this a few times, and we should have nothing. Yeah, path find returned nothing. So we can turn on our adjacent node now, and of course we're still getting that node returned. So great. Okay. So I've now got an adjacent node. So we need to process this node, and we need to. Let's just look at Dijkstra's algorithm again. So set the non-visited node with the smallest current distance to the current node. So we've done that. For each neighbor n of your current node C. So we are looking at a neighbor now. Add the current distance of C with the weight of the edge connected. C to n. It's smaller than the current distance of n, so there's a new current distance of n. Add. This is really important. Add the current distance. Because these build up, right? So C at the moment is 0. But the weight is going to be 1. We want a weight of 1 every time. So we're just going to increment. We're just going to add 1, essentially, to our weight. So how do we do that? Well, we've got distance, I think. Let me just make sure. So add the current distance, yeah. So let's have a look at our node. So we've got distance here. Our root node has a distance. We haven't created a root node yet within our list. So we've identified the node we want to target by an actual link to the node itself. So we've now got access to all the information here about this node. So we're now going to add a new node. And it's unsettled. This is the bit that I struggle on. Let me just look back at this again. Yeah, it's not visited yet. So that's fine. Okay. It's like never having built an engine before, building the engine, turning the ignition, and wondering why it's not starting. I think I'm going to get something like that. Okay, so we're creating a new unsettled node, essentially. We'll call it new neighbor. I'll just set it up here. All right, so we're setting a new neighbor. But wait, what if it already exists? How do I know what it is? Because it's adjacent. So I don't know if it exists yet, right? It doesn't make any sense. I do want to look it up, I think.
Oh, I managed to catch the tail end. Nice.
And I am just banging my head against the wall here. You're catching the tail end of an absolute nightmare. Worst of all, it's 20 to 11 here, and I don't know if I'll sleep if I don't get this done tonight. And if I come back to it tomorrow, I'll probably start crying. I hate like not finishing something like this. I need to get it done. I'm literally sweating at the thought of not getting this finished. I'm really struggling though. So I think I
can take a look at it for you.
I think, you know what, Ender? You could. And one bit said the same thing, but I really, I consider this a personal challenge, man. I really want to work this out and have that satisfaction of having it working. Anyway, while I've got you here, I had a proposal on GUI. Don't know what you think, because, I don't know if you've caught much of the sort of philosophy I've got for this. And that is that I want this to be something that we can create with as little requirement for thousands of assets as possible. I don't want to have to require 20 artists and 3D modelers and, excuse me, the Tesco oranges getting to me. I want something that, most people could pick up, and then they could record the voices themselves if they wanted, and just add the audio that they need to create this adventure game, and the dialogue through Dialect Designer, which I've sort of integrated in. So what I wanted to create was some sort of GUI. That's where I really suck. Like, as you can see, the GUI is awful. So I was wondering, perhaps we should have like a book, right? And inside that book, we have some sort of graphical representation of like a sketch of the location you're in. And then above it, the characters, they're in that location. Maybe they're just little faces or something with a little name. If you want to interact with that character, click on it. So you've got this sort of graphical side, and also you've got exits there as well. So so you've got so 2 pages, and on one side you've got a location that you're in, underneath it the exits from that location, and above it the characters that are within that location. And clicking on them gives, but they maybe we can make it sort of pastel-y, hand drawn, like I don't know, maybe a little bit mangry, I don't know, some stylized. But the point being that you've got the book, really the assets just like a tiny little sketch for that location. It could even be in paint or whatever, anything. Just the fact that it's actually appearing on this page gives it this sort of artistic style. And then on the other side we have what's happening. So we have script. When people say something, it gets written in, or what else do we have? We have I want to run it right now, but I'm just obviously in the middle of this. I think it's just going to keep crashing every time. Wow. Completely crashed. Not responding. Have I killed it? Yep, I've totally killed it. P node is null. Oh, jeez. Let me just do that. There we go. Should be good to go. So when a character comes into the location, like one's just about to, here it comes. So here's the AI. So that character just kind of, you get the sound and the character shows up on the page. Now you can interact with that character if you want.
I'm gonna be honest with you. I can't visualize stuff well. If you could do an on-paper sketch, I could see it much better.
Yeah, I don't know. I'm totally open to ideas. I talked to, there's an episode, if you go back, where I talked to a UI guy. And what he wanted to do was change the storyline. He actually wanted to make the user interface tie completely to the game that you're playing, which is nice, and I get the need for that. So in this case, he wanted to make the player character blind, such that he had to use some sort of neural interface to see everything around him. And because he was using this neural interface, it meant we could create like 3D a 3D interface for the character. And so we started messing around with like spatial interactions. Oops, which one is it? Spatial. That's the script. I think I showed you it before, right? That one. So in this concept, there would be objects and locations and so on, and you would interact them. If you look actually on the Discord channel, there was this. Whoop, there we go. So it's like a 3D, kind of like a virtual representation of what you'd see, and then you interact with things. But it doesn't mean we need to draw a TV. Doesn't mean we need to draw a plant. Doesn't mean we need to draw a door. They're just kind of like nodes in the network. You are Neo, and you see the code in front of you, and you're interacting with the world through the code, right? So that was one idea. The trouble with that is, what I'd really like for us to be able to do is apply the engine to other concepts. So we could do a fantasy game, we could do a sci-fi game, we could do any sort of game we want. And I'd like the interface to always work. So the only thing that needs to define the adventure would be the book cover, or some of the stylization of the imagery or the characters within the game, and the engine would always work. Because we're reinventing the audio book, right? We're creating an audio book that's more than an audio book. And I like that concept. It's like audio book plus. Audio book is like you open a book up, it says, what do you want to do? You want to do this or this? I'll do that. Let's go to this page. You want to do this or this? Click. So we're taking it a step further. And so for people that like audiobooks, and there's a lot of them, mind you, right? There's a hell of a lot of people that like that sort of interactive audiobooks. Well, here's something that is extremely close to what you're familiar with. But not only that, but now it's dynamic. These characters are moving in and out of the location you're in. Things are happening. I think that'll blow the mind, because I think a lot of people that play these interactive audiobooks are not gamers on any level. And so it's like casual gamers. Basically, that's the sort of level you're talking with an interactive audiobook listener stroke player. And we are expanding their mind by giving them something much deeper. Because we have got narration, right? If I turn on the narration, global, I can never remember how much you've seen of this so far, but I'll just imagine you've not seen anything. So we'll play the narrative. I just got a debug at the moment to turn that off. So when I start now,
I woke up. My mouth was dry. I think I left the heating on.
You can see we've got narration. So that could be written into the book, right? Not Inkle. Maybe it is a bit like Inkle. But now you've got your interaction, right? So on one page, we've got the things that we can interact with, the locations, the characters, and so on. Actually, no, on one page, characters and locations and exits. On the other page, interactions, dialogue. It's more like the book that you're reading. So you might want to, then interact with the TV. Oh, that's interesting.
Welcome to the
I noticed when the character moves.
I entered the elevator.
Hold on.
I woke up. My mouth was dry. I entered the elevator.
So if I click on one of these, I think it's refreshing the buttons when So see, whenever the AI moves, it clears my GUI. I just found a bug. The AI is about to walk into the left. Check this out. I love the fact that it just works. Here he comes. Now. Nope, there's been another 4 seconds. There he is. Hold on. Hey. And off he goes. But yeah, so I want to have we want to be able to define the sound of people moving per NPC. And of course, we've already got exit and arrival sounds for each location, including lifts and so on. And then we've got objects you can interact with.
Picture of my mum. She was 8. When I was a kid, I wanted to visit Earth, but after the death of my father, I wasn't interested in going home. Home was Europa.
Anyway, you get the idea. Of course, and we're not going to have me talking anywhere in the game. You'd be pleased to know. Maybe we'll have you talking. What's where are you from, Ender? What's your accent? Are you a good voice actor? Can we just do your voice for the entire game? Also, can you do a good male and
England
female
is
voices?
my city.
England is your city. Where in England are you?
My voice ain't good XD.
Well, we can always get a load of voice actors. Steph is busy building up. Like Steph basically
London
is...
based.
All right, cool. Steph is focused on story and voice acting at the moment. But one thing we don't want to do, we were just clarifying yesterday, is we don't want to waste the voice actor's time until we've got the functionality and the base for the game working. So I want to get the pathfinding working. I want to get a lot of stuff working. If visuals aren't your cup of tea, that's absolutely fine. Maybe we can find someone that will work on the visuals. What I'm thinking is if we could get a 3D book and we can map like a 2D...
I can try.
Yeah, so we could create a 3D book, map a 2D interface, like a 2D viewport to each page. And so you're interacting with buttons that are just text within the book. That might be a quite nice way to do it. And then our book could have a 3D background or an image-based background based on the sort of scenario you're in. Or we could have the book sort of in space, like just floating in space, and then we could have maybe some extra atmospherics based on what's going on in the game. Something that sort of adds, like those Logitech light speakers that sit at the side of your monitor and add color for some movie you're watching. And you get this in quite a lot now. People want to add lighting to the movie. I don't think it's a particularly good effect, but so we could add some sort of effect to the location you're in. So you're in an airlock. We might have sort of a glowing red behind the book. You're out walking in the sky on the grass, Zelda style. We've got blue sky and clouds passing by behind the book. Things like that. We could just add this sort of layer. Then we don't have to be literally creating every bloody location. We can just set a feel and a vibe and let the user's imagination create the location for them based on what they're hearing. That's the dream. That's what I'm aiming for. I don't know whether the book's a good idea or not, but I think maybe it's a bit... I've always thought it's a bit cliche. So, right, I'm done. Got to get Dijkstra working. Have you got any specific stuff you'd like to focus on? So at the moment, I've got pathfinding. We've got user interface, obviously, is a massive one.
I can do programming in general.
Cool.
I'd quite like to do some dry stuff like pathfinding.
Mm-hmm.
I'm not much of a graphics guy.
Okay.
I got what? AC in art. XD.
Okay, let's have a look. I'm just looking at stuff. What about...
But generally any programming I'm happy with.
The other thing we were thinking of is introducing RPG elements to it. So stats, health, combat. I thought that would float your boat, looking at that. We need a system. We have got...
I'm all for it.
Yeah? Well, we've got no system at the moment. So our player class has nothing. I think it has health. Nope, doesn't even have health. Our player class has nothing. It just has a current location and a previous location where they came from and a name. and our players in this game is Jove. It'll always be Jove. So, it's a blank slate. We can have XP, we can have strength, intelligence, we could have whatever system. Have you done much RPG, gaming, creation, stuff like that? Much experience in that sort of area?
I've played around with it.
Cool. There's so many different ways of doing it that could be more interesting than your standard, your bog standard like attack, defense, speed, critical attack and stuff. I mean, there's something I quite like about D&D. Might just be that it takes me back to being a kid, to be honest. But when you start looking at like these modern role-playing games, this just looks like still looks like D&D to me, but this sort of thing, like feats or proficiency, introducing interesting concepts to the game that can be worked in with the puzzles, worked in with the combat, that would be really cool. Love something like that. So when the game starts, although the player might always have the same name, maybe it won't, but I think in this case, the player will have a voice. The player will be able to narrate. The player will always be a male. The player will always have a similar history in that his father has an accident. But they could still have, different likes, different specialities. Oh yeah, he was a bit of a brawler at school. He did some combat martial arts in his spare time. I don't know. He's, good with a laser cannon or whatever. This is the stuff I'm talking about. Coming up with something, a system, which we can then roll out into encounters. So being able to encounter enemies in particular areas. The first whole section we're developing at the moment is purely story-driven. So to be able to add an RPG element to it, man, that would be a whole new level. And whether it's like really nerdy statistics-based stuff, or more along the lines of you can't really see it. Trying to think of a good example, like oh crap, what's that game called? Elder Scrolls. I don't think. Do you actually see the numbers in Elder Scrolls, or is it more you just get better at it? I can't remember. Some of the games where you don't actually see the numbers, you just feel the results based on what you're doing. So Elder Scrolls, you could just jump around everywhere, and eventually get better at jumping. Anyway, if you fancy looking at something like that, that would be very cool. So I just don't even know where to start, to be honest. I was looking at like roguelike elements. So
sure, not a problem.
Yeah? All right, cool. If that's up your street, there's other areas as well. Doesn't have to be that. But the other one is the dialogue generation. So at the moment, we've got this. Dialect Designer. I think I'm going to have to log in here. Hang on a sec. Oops. 2 seconds whilst I log in. Oh my god, Steam card. 2 seconds. Okay. And we're in. So Dialect Designer, here it comes, hopefully. Yep. So this is written in Godot. I don't know if you saw this episode. And So if we create a character in the game, we can design the entire dialogue system for that character in one map here. So for the whole game, we can say we're going to create Ender, and we'll have the player. So we're going to be interacting with. Player already exists. What am I saying? So this is going to be interaction with Ender, right? So we have a starting point. So the player says hi to Ender, right? And Ender then responds, right? So we pick the character. So Ender says, who are you, right? Now as a player, you now have your choices, right? Okay, so whatever. This is a typical dialogue generation system, right? So choices are, I am your father, or whatever, right? Blah, blah, blah. And we don't need this slide camera stuff. There's a load of redundant stuff in here. I emailed the guy that created this. I think he's done an amazing job with it, but the JSON that it spits out is absolutely awful. The parser is a little bit OTT. It's not really what we need. But look at this cool stuff. So we could say now, if you picked I'm your father, then it's going to give you a random. It could do a number of different things based on what you just said. It could also execute some code. So it might call a function, or maybe it'll wait for a few seconds while the guy blinks and stares at you. Why would you ask such a stupid question? And it might have another dialogue. It might have a conditional branch. Did something happen before? We can set variables. These are hooked up in the game, so there'd be global variables we can check to see whether something's happened. And so, as you can imagine, yes, you've got this initial scenario where you meet Ender, but as you progress through the game, Ender knows where you are in the game because we're setting local variables. We're reaching certain points in our we could have a conditional branch at the beginning. If you're on Act 2, then we're gonna use this dialogue tree. If you're on Act 3, we're gonna do this dialogue tree. So you can create one single dialogue script for this entire game for this one character. It's huge possibility. So here's an example that we created. So this is a conversation that you saw earlier in the cutscene. I don't know if you saw it. And this is just you basically saying you don't want to see your dad before he pisses off. And then your dad dies and you're like, no. So here's the bad stuff about this. What's great about it is it's going to give us some JSON, right? And if we go into Godot and we go into our game script, we scroll up. So we've got our characters here. I'm going to go into my AI. I've got a game script here where I've got AI. And how do we interact with AI? At the moment, it starts a cutscene. We're going to turn that off and we're going to have an interaction with the AI. What is our interaction with the AI? Well, we define our cutscene here. That's our interaction script. That's what we exported from Dialect Designer. So now if I play it.
I woke up. My mouth was dry.
Yeah.
I left the heating on.
So as soon as the AI comes in the room, we can start talking with them. I don't know how well this will work because the AI will leave 5 seconds later. There he is. So we click it. Good morning, Jove. I trust you slept well. Like a baby. Good to hear it. See you later. And he's going to piss off. Off he goes. Right, so Dialect Designer lets us to do that, right? But it doesn't let us define audio. So we can't have this script playing an audio script that goes with it. It doesn't really work completely well with this. It's very much designed for the sort of game where you just want to plug in
I woke up.
one of these systems.
My mouth was dry. I think
Yeah.
heating on.
This is just typical of these sort of games, right? You see it all the time. Very nice, very pretty. But can't we move this stuff into our book, can't we? What can we do? That's the question. So there are open source systems for creating dialogue in the same way that dialogue designer works. Open source dialogue designers. I've done a complete episode on it. Right, Yarn, for example, right? Yarn editor. So this is just like exactly the same thing we just saw. It's not quite as pretty, but this is extendable. It isn't closed source like Dialect Designer. We can say, you know what? I want each of these to have an associated audio file. I want to, we can basically customize it and bolt stuff on. So that is another potential thing that we need to do at some point. I really like this. If we could somehow work out how to bolt onto this, that'd be great.
TBF, this shouldn't be too hard.
Yeah? Well, there's Inkle, obviously. Inkle and Yarn.
It's easy to represent the tree.
Cool, yeah. Well, that's the thing. So it's really just JSON, right? Have you seen the Inkle editor, yeah? It's really nice. Inkle Writer.
I can look at this stuff if you want.
Yeah, if you want to have a go.
I'll be right back.
Okay. I think someone's already had a look at this. So there is a GD. I've seen a Godot ink plugin. So I got way distracted there, which is okay. Another hand on deck to help complete the vision. Be great to have Ender on board. So we were looking at our character script. Let's make sure we're still working okay.
I woke up.
Yep. I'm going to need to turn off my chat. So, so we're creating this network of a network of nodes. So when we find an adjacent node, we need to add that adjacent node to our list of unsettled nodes. Only if it doesn't already exist, right? Let's have a look at our comments here. Only increment distant values in all location dict if the value is smaller than the current value. If you exit to other locations. Okay, so you add this node. This is where I lose track of the big picture here, but going back to our algorithm here. For each neighbor n of your current node, so we're on C here at the moment. We're looking at A right now. Our distance is 1. We're going to update the distance in A as 1. So as we find it, we're adding it to the network. But it's not completed yet, so it's still going to be unsettled. and it must be added if it doesn't already exist, because we're discovering our graph blind in our case. It's so much easier if you think for yourself rather than looking at another solution. So add this node if not visited. How do we know if it's visited? It would be settled. So if not settled, so that way we've got to check to see if the node has been settled. So I'll just write a quick function here. Func is settled. Node name. And all we want to do is pass in. Wait a minute. Do we want to check if it's, because we actually remove it from the list as we process it. So at the beginning, we add the node to our unsettled nodes. And then we start looping through all the unsettled nodes. We get a link to the current node, and then we remove the one we're looking at because we're about to finish processing it. Semicolon. Yeah. So actually the question is unsettled. And we're going to pass in the list of unsettled nodes. So does it already exist in our list? So we're going to step through for, I suppose we're going to do some kind of for node in unsettled nodes. Because it's an array of root objects. And if node name equals, so the node name we pass in, if it's equal to the node we're looking at's location name, I think that's what it's called, location name, yeah, then we found it, right? Which means it is unsettled. Otherwise, we didn't find it, so I'm going to return false. So let's put that into action. So add this node if not settled. So it is unsettled. Passing in. So it's adjacent node dot. Is it just name? What's it called? Location underscore name. And then we're passing in the list of unsettled nodes. So if is unsettled. So if not is unsettled, then we're going to add it. So we're going to do that, right? What if it's a settled node? Christ's sake. Okay, so create another function. You know what? Actually, we're just going to change this. We'll just say exists, right? If node exists, node name, search array. Okay, so generic function. Now we can say if the node doesn't exist in unsettled nodes and the node doesn't exist in unsettled nodes, then we want to add it to unsettled nodes. It's not source, it's adjacent node, right? That's not right either, though, because that would be adding an actual node to our list, but we don't want to do that. We want to add one of these root nodes to it. So we actually want to declare flipping it. What do we call it? Oh, it's new neighbor, isn't it? Did we set that up somewhere? Nope, we haven't used it yet. So this new neighbor we want to be appending. We've definitely not used that anywhere. Nope. So we actually want to be doing this before we do that. So it's a new neighbor we found, and our source distance is always going to be to our new neighbor. So we didn't find him. So this is a new neighbor with a distance of 1. We'll always have a distance of 1 in this case. And then we add it. Else, we found it, right? Crap, where did we find it? Actually, it doesn't matter because really, it's not really an else I think we want. We only want to add it. So if it's an unsettled node, and we did find it, then we want to increment the distance, right? I need to do it this way around, otherwise it's going to find it. Now we've got to make sure we've got our target right here. So it'll be in unsettled nodes. So we need to actually find the node in unsettled nodes, right? So we need this to return. The node exists isn't good enough. We need to actually return an index. Okay, so if you find it, return the index, otherwise increment the index. Yeah? Otherwise, it'll return false. So it's going to return an integer, or it'll return false. Okay, so we're going to tweak this function here. So that still works. And that still works, but new neighbor doesn't exist. New neighbor is something we add later based on an adjacent node. In this case, we've got the existing node, so it'll be the node exists. So it's unsettled nodes. Can we just assign a value in the if? It's a bit crap running it twice, I suppose. We'll just do this. We'll just store a node index. This is the most ridiculous mess ever. We're going to store a node index. Save the node index here. This node exists. And then rather than doing this, we say if if node index is not false, essentially. I think that'll work. And then we've got the index now, so we can increment the object inside inside unsettled nodes. So we're referencing a given node inside unsettled nodes. Okay, so what we're saying is, if the node exists as an unsettled node, then add to the distance. All right, and it's plus equals 1. If that's right, so for each neighbor n of your current node, add the current distance. If it's smaller than the current distance of n, set that as the new current distance of n. Okay, so that means we actually have to do a check to see. So for each neighbor n of your current node, so it's A, B, and C. Let's just go up a bit. Look at this again. So that's C is our node. We can check the current neighbors in no specific order. Fantastic. So we're looping through the exits. We begin with B for some reason. We have the minimum distance of the current node. Oh, right, okay. Of the current node. Ah, right, okay. Alright, I'm going to go through this. It's actually better. Okay. Compare that value with the minimum distance of B. Infinity. This value is the one that remains the minimum distance of B. Right, okay. So we want we always want to store the lowest value in distance. So we're checking to see if it's lower than the last value we had. So we have already got this function, which is get lowest distance. But this looks through them all. I think this is like a slightly different approach in the Java routine to the way we were doing it. Flying blind here a bit. Okay, let's just do that though. So we don't want to add 1. We want to add the current node. So current node should be it. So we're going to plus equals current node dot distance. So we're, in this case, on the first node, we're adding 0 to we're adding it to 99999. Let's just look at that. Because we're saying B is infinity, right? We haven't got a weight yet. We haven't got a weight. We need a weight for our exits. Let's do it. I fancied this anyway. I think this is really important. Our exits need a length. It's really how long it takes you to get to the living area from the balcony. So let's weight this up. I don't think we needed to use Dijkstra's algorithm here. We could have created something much simpler. Now I know how it all works. But actually adding this could really add a little bit more flesh to our game and the route characters would take if we have complicated locations. So we're going to add a new exported variable for our exit, and that's going to be we'll call it distance, right? And it's a number. Export int var distance. Super. Okay, so now we need to step through all our exits, define our distance. So this would be the shortest distance. Balcony, study, going to be 1. Again, study and balcony, it'll be 1. I'm going to make the lift slightly further away. And again, lift, it's the same lift here, exit into the living area, so it's that further away. We should maybe have some sort of check as well to make sure that the exit distances match up. And then we've got floor 2. How long does it take to get to the second floor? Let's make that a 4. And then same thing here. Floor 1, 4. So that's moving up and down. Exit into R&D. We'll have it at 2 again. So exiting the lift is always going to be a 2. Moving in the lift is always a 4. And finally, again, a lift location is going to be a 2. That's it. So we now have distances for all our exits. Fantastic. So that's our weighting. So looking back at our weighting diagram, we have the minimum distance of the current node, in this case 0, the weight of the edge. So now we're not adding to B's, we're adding the exits. And we're comparing that to B. If it's lower, we'd take it, right? All right. So we want to let's set up another node here called weight. And we set the weight when we find a node. So we're going to set weight here. Weight equals exit dot distance. Okay. So here now, we're not adding the current node's distance. It's the weight. Oh, wait. Wait. We're comparing it to current node dot distance. So, okay. So, set up another one called checksum, and we're going to do a checksum equals weight plus current distance. Right. Our unsettled node is currently going to be 999, so we're adding it to the current distance, the current node here, right? And then we're going if the distance, if 999, if our checksum is lower than this infinity weight that we've currently got on all nodes, then we want to replace this distance with checksum. Okay, we are closer. So if the node is found, then we're going to update that information. If the node isn't found, then we're going to add it. And we know the distance is going to be the current weight, right? Not 1. So it's just going to be weight. That's not right either. The first time we find it, we don't want to declare it yet. We're just going to add it, right? Maybe we do want to change the order we do this in. At the end of the day, we don't want to process if it's settled. So why do we need to check if it's settled here? That's just going to break it. Oh, because we need to know if we need to add it or not. So if it doesn't exist in either, we want to add it. Okay, yeah, so the add, we need to do the add first. If it doesn't exist, add it. Now, if it's an unsettled node, which it will be at this point if we added it, then update the weight. All right, I think, is that going to work its way through the whole thing? I think there's one thing we haven't done yet. Oh no, I think that should, yeah. Let's see what we end up with. I don't think if that's going to work yet. Invalid index null and base array. So current node index is set to what? Null. Where are we getting current node index? Current node index get lowest node distance. Yeah, I don't think this is going to work. I'm pretty sure that this isn't the right way to do it. I think we're looking at a completely different method there. There's a bit of logic here. It's this bit here. We now need to pick a new current node. That node must be the unvisited node with the smallest minimum distance. Yeah, all right, so we've set that to 1. Okay, all right. Okay. So let's update this function here. To opacity in unsettled nodes. Doesn't matter what this lowest distance is. Or maybe it does, I don't know, but so we're stepping through all the nodes in unsettled nodes, saving the distance. Let's just see what's coming through out of this, because I can see what's wrong with it. Definitely something wrong with it, though. So at this point, unsettled nodes is an array of one object, and that object has a distance of 0. So it's our current object. It's the only thing in it. So we step through, and obviously it's just going to give us lowest distance node is going to be 0, right? Lowest distance node 0. Okay, it'll update, but it's still just going to return 0. Yeah. So at this point, we know current node is our current node, which is unsettled node 0. So unsettled nodes is an array of size 1, which is 0, which should work. Boom. Okay. Now we remove it. We get the next target node. Have we got that? Yes, we do. If it isn't null, well, it isn't null, so that's fine. Step through all the exits for this. So our current exit now is object 1487, which is back to the living room. So we're looking at the living room route. So it's going to target the living area as our object in our next step. So let's go through. Okay, so the distance to the living room is 1. So weight will be set to 1. Boom. Now we're going to try and get a link to that node. Adjacent node is set 1490. That's the living area. If the node doesn't exist, it shouldn't exist. So it's going to add it. So unsettled nodes now has 1 node in again. This time it is an empty. Ooh, there's a problem. We didn't give it a name, did we? So new neighbor dot location name equals adjacent node dot location name. I think that's location name, right? Yeah. All right. So now our neighbor, we've created a new node. It's already got a weight of 9999999, and now it's got a name. We add it to unsettled. So I'm just going to update our list here just to make sure that was done. So new neighbor doesn't matter anymore. Unsettled nodes. Go into unsettled nodes. Oh. Yuck. Okay. It adds new neighbor. That's okay. Yeah, so it adds new neighbor. I hate this. Oh, God. Okay, right. Phew. I thought that was inside the array. I was like, what? Why has it got 2 results? Okay, so it's got 0. It's this object in here. But it hasn't got a location name. The location name should have been living area. Super. Right, we're back in business. We're going to continue. Now we check to see if that node exists and unsettled that, because that would have failed before, right? So node index should be 0 now. So that was the problem. So now we should be good. All right, let's take away our breakpoint. I don't even know where I put the breakpoint. Let's just hit continue. There it is. I've got another null on current node index. So current node index, get lowest distance now. Let's see what we've got at the moment. What have we got? Unsettled nodes is an array of the same thing. So there's nothing new in there. It just failed. Let's put our breakpoint in again. This time we will run it from the start. And we'll let it run once. And this is where it crashes, right? Yeah. Okay, so let's see why it's failing on the second run. Run once. Okay, so get lowest node distance in unsettled nodes. So it's going to be, there's no more new unsettled nodes in here at the moment. So unsettled nodes now has this object in it. It still has a distance of 9999. Okay. What's going to fail here? Lowest distance node is null. Okay. Node distance equals node dot distance. All right, what's node? 1610. Okay, so we're looking at a different object here. What's that? That's ooh, right. Okay, so that's our new root node with living area. Okay, that's fine. So node distance will now equal 999999. What's our lowest distance? Lowest distance is also 9999. So, oh. So now lowest distance node is this function doesn't even work. Shouldn't we just set it to 0? Let's try that. Should never be null. Alright, we're away. Children based null instance of null instance. I know a certain person that will be punching me in the face right now for my nulls. Are you there? You know who you are if you're watching. I'm sorry, I can only apologize for my nulls. So many nulls. Okay, so what is my null instance here? It must be target node, right? Yeah. So there was no target node set up here. If target node equals null, then tell me it's null. Hey, lift floor 1. There you go. It worked. Didn't push the error very well, did it? Lift floor 1. What? Where the hell have I written that? That's the location name. Okay. Oh, I see. It must be this one. Yeah. So what I'm saying then is that can't use location name. We need to use name. We need to use the node name. I'm getting location name. So target node is current node dot name, right? There we go. That's fine. But the others is not. So there we go. Let's try that again. Okay. No. Okay. So that is location name. Where am I setting? Here. So that's a real node. So we're checking the name of the node. And we're setting it to the name of the node. And we're checking if it exists. Okay. Please. Oh, Christ. Full on crash. Jeez. Oh my God. Still not working. Okay. Oof. Excuse me. Well, I don't know what's broken there. I'm just going to kill it and start again. And here we go. Nope. Completely banjoed it.
Jesus Christ, it is hard to set up C# with Godot. Furious smiley.
Yeah, you're a C# developer, right? What you going to, what editor are you going to use? Spiggy is now
I can
playing
do CPP and C#.
Man.
Visual Studio.
Fancy learning a bit of GD script?
I tried VS Code but it W2 as awful.
Do a bit of GD script, you get your Python
Couldn't
skills.
even get debugging to work. So that's a no-go. At this rate, I might have to XD.
Honestly, the GD script is like, I mean, I've never used it before. I've never even programmed in Python before. But it's pretty nice. Can't complain.
I know Python as well, and GD script doesn't look too bad.
Yeah, it's super stable. I think C# you get better performance from, but we're not looking for insane performance here. And I think GD script you get better stability from.
But I'm gonna be faster with stuff I already know.
Yeah, well, but then again, it'd be nice if we had like code base of just Python.
4x perf.
4x perf. Wow, bloody hell. I've totally screwed this. I don't even know if I can undo anymore. Nope, I can't undo. So I do know what I did though. I replaced all these location name. I know that's wrong. For a fact. But it's the only thing I know I changed. So now I should get a null error. Yeah, super. Alright. So,
I can do stuff in C# first, then translate to GD script.
Yeah? I think whatever you're comfortable with. So, guys, I'm going to end the stream now. I'm going to have a quick word with Ender Rifter before I call it a night. I was hoping we'd get this finished today. Really close. I'm waiting for that magic moment where it just works. But we will come back to it tomorrow. And thanks for joining us. If you have, maybe you've learned something. I don't know if I have or not. I've got a better idea of how Dijkstra is working, but I've not got the full picture yet. So one more session, I think, one more. So thanks for joining us. Have a wonderful evening. Have a fantastic Friday night. Do some cool coding. Make something fun. And I shall catch you, Ender, in Discord. Cheers, everyone. Take care. Have a nice night. And bye-bye.
Watch out!